In this video, we'll be looking at exponential growth and decay. Our essential question will be, how do I write equations for exponential growth or decay and solve them? So we're going to need to be able to write the equation and then solve them. So we're going to use the equation A equals P times parentheses 1 plus R raised to the T. And now we have to identify what all these letters mean. Well, A equals the final amount. So this will be the amount we're solving for. P is our starting amount, also known as the principal. R is the rate. We must turn it into a decimal. And T stands for time. Now the reason why it's a plus sign is it's growth. So growth, so make a note of that. Growth uses a plus sign right there. So when we decay, what will that plus sign turn into? A subtraction sign. Okay, so if we can identify all four of these, if we can identify three of the four variables, we want to identify our P, R, and T. We plug them into our equation, use our calculator, and we'll get what A equals. So in 1992, India had an estimated population of about 886 million people and was growing at a yearly rate of 1.9%. At this rate, what will the population be in 10 years, in 50 years? So how we would do this is we will identify the pieces we're given. So 886, that's our starting amount. In 1992, there was this many. So we can say P is equal to 886. We can write million, or at the end of the day, we can use the word million. So I'm going to say 886 million. But when I do my math, I'll just use the number 886. And then I can just write the word million with my final amount. We know our rate is 1.9%, but we need to turn that into a decimal, so we'll move our decimal twice, and we get 0.019, filling in this blank space with a 0. And then our time, we have two different times, one's 10 and one's 50, so we'll do this equation twice. So we'll look at time equals 10 for our first problem, and then for our second problem, time equals 50. So this is two different problems where this question's asking us to do. Now we just plug these values into our equation. So we'll say that A is equal to, this will be number 1, A is equal to our principal, our starting amount, 886, times, I don't have to write the times because I'm just providing my parentheses, 1 plus, it's increasing, so I'm using a plus, r, my 0.019, 0.019, close my parentheses. We're going to raise that. This t is in the exponent, so I'm raising that to the 10th power. Now in Alex, on your calculator, you can type it exactly like this. 886 parentheses 1 plus 0.019 close parentheses exponent 10. You can type it just like that, hit the enter button, and you've got your solution. So when I do that, I will get that there. So this comes out to about 1069, and then we'll call that million. So since this is a million, it's a thousands, this actually becomes a billion. Like so. So 1,069,000,000. Okay, that's how. So it's all about identifying the pieces. Oh, and then if we want to do the second problem, our second problem will just be the same process, but instead we're going to use 50 instead of 10. So 886 times the 1 plus. It's a plus because it's growth. There's always that 1 right there. We plug in our rate. And then we raise this to the 50th. Again, just type this exactly how you see it into your calculator, and then you'll get your final answer. So we just have to simplify that. But I'm going to move on. So that's how we can use this equation to find increase, or growth, I should say. So what happens when there's a decay? So let's flip over to the back, and we'll look at decay. So decay, the equation's the same. We will have A equals our starting amount times 1 minus r, and we raise that to the t. And the variables stand for the same thing. A. Starting amount. I'm sorry, not the starting amount. Final amount. P. Starting amount. R. Rate. Turn into decimal. And T is our time. So we identify everything, we plug it into our calculator, we hit enter. So the value of a car is $21,500. That's our current amount. It loses. So when we see words like lose or decreases, any kind of word that has like a kind of subtraction kind of aspect or a negative kind of aspect, that's going to be a decay. It loses 12% of its value every year. Write a function that represents the value of the car in t years, then find the value of the car after 6 years. So we're going to first create our equation. This first part, write a function that represents the value of the car in t years. That's just creating this equation right here. So we can say A equals my starting amount. Well, let's just identify them all and then we'll plug them in. So we know the starting amount is P is equal to 21,500. We know our rate is equal to 12%. Move my decimal twice and I get 0.12. And we know the time that they're interested in is 6 years. So we'll take. So first let's build the equation, then we'll plug t in. A is equal to 21,500 times 1 losing, so since it's losing we're subtracting, 0.12. We want to raise that to the t. So when it asks to write a function in terms of t, that's when we just write the variable t in. And now we know what t is, so we can plug it in. So A is equal to 21,500 times 1 minus 0.12 raised to the 6, like so. We plug that into our calculator. You can type it exactly like you see it. And then we get that the value of the car after 6 years is 9,984.70. So by losing 12% of its value every year, it's gone down quite a bit. It's also almost half of its value over a 6-year span. Okay. So on our compound, so that's how we find decay. Now moving into compound interest, we're just introducing one more aspect into the equation. The equation is going to essentially stay the same. We just have to incorporate the idea of compounding. So that means I'm splitting something up within a year. So we'll use the same equation where we have A equals P times, here's my parentheses, 1 plus, and this is where it gets new, is we have R divided by N raised to the N times T. So the only thing new we're introducing into this is the N part. So N I'm going to put over in our question column. N is how many times a year is split up. So what I mean by that is we have words for this. So when you see the words like annual, that tells me that N equals 1, because it's happening one time per year. Semi-annual. How many times a year does something that is semi-annual happen? Well, that happens 2 times a year. Maybe you'll see the word quarterly. If we see the word quarterly, then it's a year split into quarters, so we say N is equal to 4. Might see monthly. And that tells me, well, I'm splitting a year up into its months, so N equals 12. And daily, we'll assume it's not a leap year and use N equals 365. So based on the words you see, if I see annual, I'll use N equals 1, plugging into my equation. If I see semi-annual, I'll use N equals 2, plugging into my equation. If I see quarterly, I'll use N equals 4. Monthly, N equals 12. Daily, N equals 365. Just plugging that number straight into the equation, typing it like we see it into our calculator, and then moving forward. So let's do one of these examples, and then we'll be done. We're going to be plugging into this equation. So it's the same idea. Starting amount, principal, rate is our percent turned to a decimal. N is the new thing we're introducing using our words, and then T is for time. So I want to do B instead of letter A, so we can really see how this works. So let's identify all our different pieces. You deposit $6,000 into an account that earns 4% interest compounded quarterly. Write a function for the balance after 2 years. What is the balance after 3 years? So our principal, our starting amount, is $6,000. That's how much we're depositing. Then our rate is 4%, which we turn into a decimal, 0.04, moving that decimal twice to the left, filling in our blank with a 0. Looks like this. Fill that blank in with a 0. And then we have the n is our new piece. So compounded quarterly. Well, if I'm compounded quarterly, how many times am I splitting up a year? Well, I'm splitting it up 4 times. So n will equal 4. So we have n equals 4. And then we'll have our time, which is after 3 years. Now we just build this equation. I'm plugging in to this equation up here. So I have A is equal to my starting amount, $6,000, times 1 plus my rate, 0.04, divided by my compound, 4. Then I'm going to raise all of this up to the 4, and then we'll use our variable t for now, 4t. That's what the function will look like. Now we can simplify some things. The only thing we don't really even need to simplify anything. We can type it like we see it, so I can type it just like this. Now I'm going to raise that to the 4 times 3. So that would be probably the easiest one to simplify this, turn that into a 12. So what you're typing in your calculator will look something like this. 6,000, parentheses, 1 plus, type this division just like we see it, 0.04, divided by, just insert that fraction right into those parentheses just like that, and then we'll turn this, we can multiply these together and turn that into our 12. Now it's as simple, you type it just like you see it, 6,000 parentheses 1 plus fraction 0.04 in the numerator, 4 in the denominator, close parentheses, exponent 12, hit enter, and we get that our amount is equal to 6,760.95. And that's how we can use the compound interest formula to help us pretty much just plug these values in, be able to type it correctly into a calculator, and then send the answer on its way. But thank you very much for watching this video, and I hope you have a great rest of your day.